So we've got our parallelogram. Point P has coordinates of 5, 8, and R has coordinates of this, and vector PQ is given by this. How are we going to draw a parallelogram? What are we going to do? How are we going to draw this? Okay, but where's PQ and R and S? How are we going to draw it? Well, point P has a coordinates 5, 8, and R is 32, 17. P and R are going to be like, say, this could be P, this could be R. I guess over here could be, Q. We're going to draw it like that, or how are we going to draw it? How are we going to draw it? Okay, but how does that work? Because PQ is the vector. We go across 20 and down 15. So how can Q be there? There you go. So Q's here, is it? Is Q there? Where's R? 32 and 17. Coordinate P has 5, 8. I want you guys to tell me. What do you think, Heather? P's bottom left. And R is top right. And Q's here. Now remember that a parallel, it doesn't have to be like vertically across. It could be on an angle. It could be sort of like an angle like this. Is that a parallelogram? Could be. Could be like that. But it helps to draw a picture first, doesn't it? But we're trying to visualize this parallelogram. So how do we draw it? Could be. Yep. Slightly. Yep. And Q over here. Oh, okay. So you mean like this? All right. But are they parallel? Oh, okay. All right, we're going to go with this for the time being. Let's have a look. Let's try and there's our. Let's see if that's our parallelogram, and see how we go. We might change it. Find the coordinates Q, the coordinates of Q, and write down the vector QR. Well, the coordinates of P, OP. Shh. Coordinates of OP is 5i plus 8j. The point R has a coordinate, so we can say that OR, let's write down what we've got, is 32i plus 17j. And the vector PQ is given by this. 20i minus 15j. And we want to find the coordinates of Q. So the coordinates of Q, we want to find OQ. And we want to find QR. So what do we do? I've started you off. Let's finish it off. OQ is OP plus PQ. Yes. So we want to find OQ. The coordinates of Q is actually OQ is equal to OP plus PQ. Now that's going to be equal to OP plus PQ, 25I minus 7J. Is that right? And the vector QR. QR is the same as QO plus OR. Now QO, remember, it's the opposite of this. This OQ is equal to negative QO. So we need to go the other way. QO is negative 25I. I'm going to flip the signs around. Plus 7J. And OR is plus 32I plus 17J. Equate those components. We've got 7I plus 24J. Is that right? QR, 7I plus 24J. Let's see if the answer's right. Yep, that's right. And 25I minus 7J. Okay, so we've done part A. This is actually a pretty easy question. It's not that bad. It's just the visualizing. And to be honest, you didn't even need to draw this parallelogram. You didn't. You didn't have to draw it, but sometimes it helps you. So let's have a look now. We've found QR. So our drawing is actually not correct, is it? Because QR, it goes up across 7 and up 24. So perhaps QR across 7 and up 24, maybe it's like here's Q and here's R. Yeah? So this parallelogram is actually sort of on its side. If this is a parallelogram, then that means that this is going to be parallel to this side. So it's sort of like a parallelogram, but you know, we don't have to consider that the parallelogram is just lying flat and it's nice and easy. It's sort of on the side, isn't it? So sometimes drawing the picture helps, other times not really necessary. I think you should always try to draw a picture when you can. Part B was saying write down the vector RS and show that the coordinates of S are this. So where is S? Does it say? Oh, okay. Write down the vector RS. What's the question telling us? What's the question telling us? It's a parallelogram, isn't it? So what does that mean? Two sides are parallel to the other, and one side's parallel to another. The other side's parallel. Yeah. Should be exactly the same vector, shouldn't it? So what you could say is that RS is the same as QP. They're the same vector. And they're also the same magnitude. So it's not a scalar multiple. It should be that they are equal. So if RS is QP, and what are we trying to find in part B? Okay. So we're trying to find what? OS. Now, OS is the same as O to R. Yeah? Plus R to S. Now, wherever we've got an RS, what can we replace it with, really? Replace it with that. Now, we've found Q to P, haven't we? Yeah. So QP is equal to negative PQ. So that is equal to OR plus, this is actually negative PQ. Okay? Because they're equal. If they're equal, then what is negative? What was PQ? 32I plus 17J. So we've got, so OS is equal to 32I plus 17J, and what is the negative of PQ or QP? So what is QP? QP is 20I minus 15J. So it's negative 20I. Yep. Plus 15J. Which is equal to 12I plus 32J? Is that what we were asked to find? Okay, so we've just proved it. Good. Is that bad? It's not that bad, is it? Okay, so we've done question 4. Let's have a look at question 5, and I believe, is that the last one? Yeah. Okay. It'll be a bit tricky, so we'll finish off with this question today. All right. Let me just pause it. I'll get you guys to have a bit of a read of it first. So I'm just going to pause this video, and we'll go through this together. Hey, all right, fine. So it's for... Shh. So you should get OP is 12I plus 4J. Yay. Easy. If you guys can't do that in your SAC, you're in a lot of trouble. The point M has coordinates KO, so I guess you could say that this coordinate here would be K, and obviously it's 0 in terms of the J component. Find in terms of K an expression for PM. Now, PM is equal to PO plus OM. Now, considering that, so OP was 12I plus 4J, so PO is negative 12I plus minus 4J. And OM is actually just K, isn't it? Yes, it is. So that's just plus K. Now, that would be Ki. So what we've got is negative 12 plus Ki minus 4J. So find in terms of K this position. So that's all that we've got. All right. So PM is that. Now, find the magnitudes of OP. Shh, please. It's really hard for me to try and explain this and talk with that background noise. OP. So we need to find the magnitudes of OP. OP is equal to what? 12 squared plus 4 squared, 144, 160. Square root of 160, is it? I hope. OM is actually, the magnitude of OM is actually just K. We only need to use the square root of this squared plus this squared if it's looking at components. But it's going directly across, so we know that the magnitude of this is actually just the length K. Now, the magnitude of PM is the square root of negative 12 plus K all squared plus minus 4 all squared. Just leave it like that. Now it says here for which theta is equal to, and hence find the value of k, for which theta is equal to 90 degrees. Now OP, and so what that is, if this angle's 90 degrees, this angle in here is 90, let's just say that's 90 degrees, then that means that this is a right angled triangle. What's this distance here? This distance here is what? OM. Is this K? Good. So this is K, and this is actually the length of that is K. Forget about the direction. So the length of that is K. Over here, where's OP? Which one's OP? One on the left. So this is the square root of 160. And this is the square root of this. So therefore, we'd have to say that this squared, we'll call this, just for the time being, make it nice and easy, A, B, and C. So we're going to have to say that the square root of 160 squared plus the square root of B squared is equal to K squared. So let's do that. Pythag theorem. Just as saying we're using Pythag. 160 plus, conveniently that square root sign is going to disappear, minus 12 plus K squared plus 16 is equal to K squared. Now, if you can't expand your brackets and not doing that, you don't do a good job there, you'll just screw up. It's pretty obvious. Really have to get good at this. K squared, we know that's going to be a K squared. Is it? K squared, we know that that's going to be a K squared, and we've got to get negative 24K out of that. And then we're going to have a 144. Plus 16 is equal to K squared. Now those K squareds are going to cancel out, aren't they? So let's get this. We've got 160 plus 160 is 320, and that is equal to 24K if we just rearrange. So therefore K is equal to 320 divided by 24, which is what? Okay, so we could just say, how about we just simplify that fraction, divide both sides by 8. Divide both sides up by 8, we're going to get 40 over 3. Let's not ever in specialist maths do our rounding, please. Like let's leave it in exact values. So we've found what our value of K is, and that happens to be right because I just noticed that it says that that's 40 on 3. That's good. Now, what I'd like you guys to do is in terms of how do we go and do part D? What do we do? Find the value of theta for which M has the coordinates of 9, 0. So what is K? If it has coordinates of 9, 0, K is what? So K is equal to 9. Now, if K is equal to 9, and I guess, is it asking us to find an angle? Find the value of theta for which M has a coordinates of 9. So is OP the same? It is, yeah? So, is it always the same? Yeah. So, I guess you have, so I'd like you to have a go at that. I guess I'll stop the video now and let's see how you go, because obviously there's only a few minutes of class. I'm going to stop there.